Project 12, Modeling the Vase. Hi, Joe Cerrone for Introduction to 3D Printing. Today we're going to go over how to create this CAD model using AutoCAD to model this vase from our textbook 3D Printing Projects. And this would be project number 12. So it's a vase, and basically the author talks about what he thought about when he wanted to go through and create this vase design. But essentially we're mostly tools based here, and so what we're going to do is we're going to look at the technique for creating that. And so we're going to use AutoCAD. He used SketchUp and then he exported the STL with a plugin. AutoCAD has an export function for STL, so we don't need to worry about that. Same for SolidWorks, you can just save it. And then he used this NetFab software to check the STL, and we can use our Dremel Digisoft or Cura software to check the model or to slice the model. When we're looking at the project specifications, we're looking at a print time of about 41 minutes using a 0.4 millimeter layer height, and that's a pretty low resolution print. Okay, the smaller the number, the finer the detail, and we're typically printing these on a Dremel 3D45 printer. 3D modeling difficulty 2 out of 5, depends on your abilities with CAD. And 3D printing, not really much assembly, 4 out of 5. We're going to use something called spiralized outer contour, which will allow the print head to move very quickly. And if we want to talk a little bit about the spiralized outer contour, what we can do is we can come back here to Content, and there is some information from the software manufacturer from Cura on this mode. And so if we go and we click on this link, and this guide it's actually from Ultimaker, a 3D printer maker, talks about all these different settings. And so they also give models that you can test them out for. And so as we look at how to make our models, we can look at how to set up these different options. And so I've located the area of the content called Specialized Modes. And Spiralized Outer Contour is a mode that allows you to convert your 3D model into a single spiraling toolpath with a solid bottom. And so you don't have to model it with the top being open. It will create that path for the printer head by itself, and it will leave the top open, because you can't really put a cover on the top once you have it printed unless you use support material, and Spiralized Outer Contour will not do that. And so here's kind of an example of how that works. And so essentially it prints very quickly because there's no support material, and it just prints the outer contour and brings it up as you go through. And so in this mode we can take a look at a number of the different settings and some of the recommendations of it. To enable the spiralized outer contour, click on the gear and you can go into special modes, and you can toggle this setting to be on. We can set the wall thickness and some of the bottom and the top layers as we go through, and bring that into our slicer to kind of get the best results that we would want. So that's the technique that we're going to use to produce this model. Let's take a look at the part as far as making it using CAD. So here's a model that I was working on. A student had submitted it and he had some difficulty with it, and so we were just taking a look at it. When you're using AutoCAD and you're going to model something like this, if I were to go and take a look at this model right here and look at the quick properties, what I'm going to find is that the object has been grouped. When we work with solid models or modeling, we don't want to group our objects. We don't want to turn them into blocks or explode them. And so ideally it should just be a basic solid. And so here's a completed model, and it's a 3D solid. And the way that we came up with this was very similar to how the author did it. We create 3 different shapes, and each of those shapes is at a different z height level. And so typically what I'll do is I'll create them all on the ground floor or at the XY elevation of 0, draw all 3 of the shapes, and then what I'll do is I'll move them with either 3D move or just a regular move command in the Z plane or in the Z axis to 3 different heights. And so if this is 300 millimeters, we can change the Z value from this one to 150 and then this one to 300, and we can keep the Z value of 0 for that, and that will stack these 3 items up. To get started, we're going to go to the D2L and download the title block for a metric template in AutoCAD. And so switching over to D2L, going to the content section, title blocks, metric title block, download it, and then I'm going to open that with AutoCAD. And so I'll say File, Open, be sure that you change the file search type from .dwg to .dwt, as this is a drawing template, and that way you can find that file. And so since I put that in my downloads, I just need to make sure that I upload or that I update the file type. Downloads, here it is, B-size mech. Alright, and so this is just a basic metric template so that when we start to draw this to the coordinates, we're not drawing in inch units in the computer world and then using metric dimensions from our paper textbook. So with the grid in the snap-on, let's take a look at the actual assignment. So we're looking at a 78 by 78 square, and the author basically does the same technique. He draws these 3D shapes. He uses something like a 3D face to kind of seal this up. That I guess would be how you would do that with SketchUp, and then he imports it into Blender, which he uses to control his 3D printing applications and to print it. So it's a very straightforward example, and I think that's kind of why we chose it, because it allows us to model and then use the 3D printer options, special options, spiralize outer contour. Alright, so we'll start off in the top view. I'm going to turn off my grid, and we can draw this using the 3D modeling. And what that's going to do is it's going to change the ribbon to allow us to have all these 3D modeling options. And then what I like to do is I like to hit this little down arrow here and show the menu bar. By doing that, I get access to all the words for the commands. And then I'm going to go to Tools, Drafting Settings, and we can look at our snap and our grid settings. Um, we could, I think at this point, we'll just leave those off. We'll start off by drawing a line, and I think I will use a polyline because this will give me a closed continuous boundary. As I bring that line out, I can see that it's beginning to track in that direction, and I'll type in 78. I'll track north, 78, west, and C for close. As I'm looking at this, I don't really see much of a line weight on that, and so I may want to go into the layer properties, and let's take a look at why. I think it's because we're going to put this on a different layer, and so let's put that on layer OBJ rather than on that default viewport layer. And so that's going to be one of the shapes, and then we can draw a second shape, and so we can just draw another polyline, and we can go ahead and set that up any way we like. We can come in here with something like this. So I kind of got a little bit off as I was making my construction, so I paused the video and I'm going to restart it. What I'm going to do here is I'm just going to offset this shape, and I'm going to offset this, let's say 10 millimeters. And then I'm going to rotate that, and so I'm going to go to the rotate command. I'll select that, and then I'm going to rotate it from this midpoint right here, and we'll take that, let's go with it 45 degrees. Now if you're having some difficulty kind of dialing in that number, check that your polar settings are on, and so that would be like that. And here's where your polar settings are right here, and so this icon needs to be on, and then these settings need to be set at something other than 90, and so 15 works great because you'll get a tracking line 15, 30, 45, etc. And then I'm going to make one more offset for the top. I'll say offset, and I'm just going to go with just 3 millimeters to the inside, make it a little bit narrower at the top. Now the next thing that we're going to do is we're going to change to a 3D viewing angle, and so what I'll do is I'll click right here and I'll grab a southeast isometric viewing angle. Any of the isometric angles will work. I guess I'm kind of a creature of habit from some of the textbooks that I would work on to do these different exercises. Now the object is going to be 300 millimeters tall, and so what we want to do is we just want to change the Z heights. Okay, now old school way of doing this was you could just use a command called elevation, and you could specify the elevation. The default elevation is 0, which is what the XY plane is at. And then you could say I want the elevation to be 150, and then you're drawing 150 millimeters above the floor, or the 0 level. And so that was kind of a 2.5D way to do it. But there's much better ways to do that now with things like 3D Move, where we can go ahead and we can then click on this shape right here, hit enter, and then we can drag this Z-axis rocket to specify how tall we want that to go. And so we could go halfway with this and say 150. Kind of lost it there. Let's try that one more time. There we go. And so we'll bring that up to 150 or anything. You can do more than just 3 of these items. You know, it will add a little bit more complexity to it. And so I'm going to get it pretty close, and then I'm going to just type 150. Now, if we back up and want to orbit this model, we can go and we can type in orbit. And I like to type the commands. We can find them in the menu as well, and I'll take you there in a minute. And you can then orbit it by clicking on the left mouse button, and you can see that it is changed in the z-axis. And so it's now, this is 0, this is 150, and then we're going to take this last inside shape and we're going to make that a 300 elevation. And it's the same way. We'll go to the 3D Move command, we'll select that shape, we'll hit enter, we'll select the axes, and then we'll drag that up and we'll type 300. Hit escape. So that's our model that we're going to work with. And it's very similar to the same construction techniques that the author